High-rise building is very common in our country, especially in KL. A high-rise building can have more than 12 floors and can occupy more than 500 people in it, which can lead to a problem during a state of emergency. During the state of emergency such as fire, earthquake, or terrorist attack, when such event happen, it is hard for the fire department to accurately count the head count of people that successfully escaped from the high-rise building. Currently, the fire department are using the counting through checklist method, which take a long time to count for the people that successfully escaped from the building. And it is important for the firefighter to know how many people are left inside the building that need to be rescued. And therefore, this project introduced a method to solve this problem, which is by using the image processing to count people through security footage, and then we will send the data to the IoT, Internet of Things, to collect the information and then distribute the information to the fire department so that they would know how many people are left inside the building. So the project problem statement is how to eliminate slow process such as counting through checklists. Then, how to collect data to be reviewed by the fire department, and how to improve the accuracy in counting humans in the building. And there is 3 objectives for this project, which is to develop a system to count and monitor the number of people in and out of the building, to implement the IoT approach to collect the data from the monitoring system and store the counted number of the human, to validate the accuracy of the method in counting human by comparing the result of the system and the actual number of humans. The scope of work of this project is we input a video to the system, and then the video must be taken in a narrow hallway, and the video is stable in a not shaky position, because if the video is shaky, then it will reduce the accuracy of the system. And then the video must be top view to avoid blind spot. And the connection must have a stable internet connection, and we have a ThinkSpeed as a IoT platform. So move on to the literature review, as the image processing. Image processing are divided into 3 parts, which is detection, tracking, and counting. Then the next part is IoT, which I will explain more on the ThinkSpeed. So for the detection, previous paper, we found that there is few methods to implement the detection. First of all is background subtraction. This system will subtract the background and the foreground, and then to determine whether there is a presence of the object. Then next is machine learning, which use a histogram oriented gradient combined with support vector machine. Histogram oriented gradient, which is like a edge detection, and then SVM, it will classify which one is the background and which one is the foreground. Another method is by using deep learning. The examples of deep learning are region convolution neural network, and then other than that is faster RCNN, and then YOLO. All these are used deep learning to justify the object that present in the video. There are multiple ways to use tracking in this project, which is partial proximity, comparing frame, and CR Kalman, and then control extraction, and then central representation and Kalman filter. For the counting part, we will focus only on line of interest, which is LOI, and it will count the object when it passes the line. So in IoT, the literature review, most of the paper use HTTP. However, for me, I will use MQTT because MQTT is a lightweight data transfer. Next, we will move on to the methodology. How this project is conducted. First, I study and research on that related to this project, and then design the system, which including of detecting, tracking, and counting algorithm implementation, and then implement IoT, and then I link all the system together, and then evaluate the accuracy of the system. So the basic design of this system is we input the video into the system, and then the system will start detecting. After an object is detected, then it will start tracking the object, see where the object will move, and then when the object crosses the line, it will start counting. So the number that counted in the counting section, it will move to it will upload it into DSys. So the general flowchart is we start the program and then input the video, then it will start detecting any human moving, and then tracking the human, whether the human crosses up or down from the line of interest. Then it will start counting, and then the output value of number human in the building will be updated in the DSys. Then finally it will end the program. So this is the detection flowchart, which it will pre-process the video first, then it will conduct background subtraction. It will extract the foreground and the background, and then it will build a bounding box to track down the object. So in tracking, it will start with it will use Kalman filter, and then update the track to an array, and then it will delete the old track if the object is missing from the image. So each tracker have its own ID. So for the line of interest, in total there is 2 virtual lines will be created in the image, and then it will determine whether it crosses the first line first or the second line first. If it crosses the first line, then move on, and it crosses the second line, it will increase the count, and then it will go to the next system. Vice versa, if it crosses the second line first and then cross the first line, it will decrease the count and then move on to the next system. So this is the IoT part for the system. First, it will establish connection to DSys, and then collect data from the previous system, which is the count of the human. Then it will send the data through MQTT to DSys, and then check whether there is error or not. If there is error, it will bypass and then continue on the system. If there is no error, then it will just continue the system. We will use the Python 3 IDE PyCharm with OpenCV library, and using the DSys platform to collect the data. The system able to count the value of people crossing these 2 lines. So this red line will be the out, and then the blue line is the in. So when the object crosses the blue line, and then crosses the red line, it will count as out. If the object crosses the red line and then crosses the blue line, it will count as in. And as you can see, this green color box is actually the bounding box, and the red dot is the centroid tracker, and next to it the small little number is actually the ID of the tracker. The think speed. So as you can see, it has the timestamp for the human record, and then the fire department can just compare the maximum point with the out maximum point and the in maximum point to calculate to know the value of people inside the building. In conclusion, this system can achieve the accuracy of 100% in given correct setting of the frame divider and the binary segmentation threshold, provided the frame divider is actually in range of 150 to 250, and then the binary segmentation threshold is 154 to 254. So for this project, for the future recommendation for this project is to apply the artificial intelligence on a lower spec PC. This is because the detection still have a lot of flaw, and then if we apply AI to identify the detection part, it will give out more accurate result